Hello everybody. These are going to be your chemistry notes. Now the reason we're flipping some of these chemistry notes is for, well, if you're absent. If you are absent and you need to get the notes, you can always go online and look up the notes. You don't have to worry about missing. Or if you went through the notes, you didn't understand a few concepts. Maybe you thought I should have gone a little bit slower. Well, you can always re-look up the notes and you can use those to fill in the blank notes, or these might be an excellent review to review right before the test. Now I'm going to break these notes. There's about 100 or so slides, but I'm going to break it into several smaller videos. So instead of having one, hour-long video or 2-hour-long video, I'm going to break it into smaller sections. And as always, if you have any questions about the notes, just ask your science teacher, and they'll be able to help you understand some of the concepts with these notes if, after the video, you still don't quite understand them. So these are going to be the chemistry notes, part 1. So one of the first questions I always have to ask is, what is chemistry? And of course you can see the definition here. Chemistry is the study of the properties of matter and how matter changes. And we're going to explore in this first section, what is matter? When we talk about the properties of matter, what is matter? And we're going to talk about how matter changes as well. Eventually, not today in this short video, but we will later on. One of the other questions that's very important, not only in chemistry but in all of science, is how does it affect you? A lot of times if it doesn't affect you or if it doesn't impact you, people don't care. But chemistry is all around you. You're made up of atoms. You're made up of elements. And how those elements interact with other things and how you interact with other things, such as the medicines that you're taking. Maybe your body interacts with pollen and you have allergies. If you get an upset stomach, it's how things are interacting. This all has to do with chemistry. So chemistry affects you or impacts you on a daily basis. So let's back up to that definition. It talked about matter. What is matter? Matter is anything that has mass and takes up space. If we go back to our last unit, we learned that you use a balance to measure mass. So matter has to have mass. We should be able to put it on that balance, be able to figure out that it has mass. But keep in mind that our balance, however good it is, only measures to a certain degree. When we talk about some things, they're going to be so small or they're going to be so heavy, our balance won't measure them. And they need to take up space. What does that mean? We've talked about things that take up space. We use the word volume. But matter is anything that has mass and has volume, or in other words, it takes up space. So, can you always see matter? Can you think of anything out there? Anything at all that you can not see but might be considered matter? Think about it. What's all around you? If you're thinking of air, you're right. Look at air. You can't see it. Usually can't see it, but you can't see it. But if we took that air and we filled the balloon with air, we would see that it definitely takes up space. But does it have mass? We'll try this experiment. Take an empty balloon, put it onto balance. And when you put it onto balance, it'll have a little bit of mass because it has the balloon itself has some mass. But then put a lot of air into it and put it back onto balance. And I bet you when you rebalance it, if you put enough air in there, you're actually going to be able to measure that mass. How about this question? Is everything you see matter? And some people will debate this, but what about light? I can't blow up a balloon with light. It doesn't have mass. It doesn't take up space. We can occupy the same space as that light. So just some things to think about. So let's get a little bit closer and let's talk about matter. So let's get into things called atoms. Matter is composed of building blocks called atoms. Are you matter? Do you take up space? Do you have mass? Yep. So you're composed of building blocks called atoms. In fact, you're made up of billions and billions and billions of atoms. Now, the arrangement and the type of the atoms give matter its properties. And this is a good thing. Now, you and I are basically made out of the same type of atoms, but yet we look very much different. Why is that? Well, it's the arrangement that gives us our different looks. In other words, the arrangement and type of atoms give matter its properties. You and I, it's the arrangement that has us looking different. So, can you see an atom? No. You cannot see an individual atom. But then, if you can't see an atom, some people say, well, how do you know they exist? How do you know anything about them? Well, scientists observe atoms by the way they interact. Think about it this way. If on the first day of school, I could hear you in the hallway before you even got to the room. I didn't really know who you were, but yet I can listen to you and I can see how you interact with other people just by listening to you. And just like I can start to figure out who you are before I even meet you just by the way you interact with others, scientists do the same thing. So they may not observe necessarily one atom interacting with another one atom, but if you put lots and lots of atoms together, you can see those. You take a small piece of aluminum foil. It's just lots and lots and lots and lots of aluminum atoms put together. You can see how they interact with other atoms. And once scientists start figuring out how they interact, they develop models to help explain the interactions. Now there's three parts to the atom. The first part is going to be the protons. These are going to have a positive charge. That's why I, behind it, put a positive sign. So when you look at it right here, you see that right there? You got the positive sign right here. It's blue ink, so it's a little bit hard to see, but you have the positive sign. That's because they are positive. Now, right below it, you see that there is neutrons. Now, when you look behind a neutron, did you notice back here there is no charge? So you might be asking, why is there no charge? Well, that's because it does not have a charge. It is neutral. And when things are neutral, they have no charge. Go back to social studies. What did you notice about, you ever learn about Switzerland during World War II? They were neutral. They weren't for one, they weren't for the other. They were neutral. So there is no charge. And then finally over here, you have the electrons. The electrons have a negative sign. What does that mean? That means they're negative. So protons, if you're pro something, you're for it, you're positive for it. So if I'm pro-environment, I'm for the environment. Electrons are negative. So these are the different signs. So when we take a look at this slide here, this is it an actual atom? Let me ask you that. No, it's not. Remember, you can't see an individual atom. This is a model of an atom. And when we look at this atoms, over here on the outside, I'm just going to quickly change ink colors here. Let's go to blue. And when we look out here, you notice these are the electrons. Now, even if this was not here, if I took this away, would you be able to figure out that this is an electron? Yeah, because it's got the negative sign. When we look in here, you look at these different ones. You got the protons, and they're pointing to the ones that are positive. And you got the neutrons right here, and if you follow this down here, it's pointing to the ones that have nothing on it. Now, I didn't call this out in the last slide, but inside any atom is something called the nucleus. And inside the nucleus, you have neutrons and protons. On the outside, sometimes this area right here, outside the nucleus, is called the electron cloud. And here's a question for you. I'll test your knowledge. What kind of charge would the electron cloud have? Well, right here is a clue. What kind of charge would it have? Yeah, it would have a negative charge. How about the protons? What kind of charge would the protons have? If you said, I don't know, well, you're not right, because you should know. They would have a positive charge. You might say, well, what about the neutrons? Neutrons are neutral. They have no charge. So the nucleus has a positive charge. The electron cloud has a negative charge. So what do you call a substance that has only one type of atom? We call those elements. And where do you find a listing of these elements? You find them in a periodic table of elements. Now, just a few more words about the periodic table elements before we end today. You know this guy? Anybody ever hear of Dmitry Mendeleev? He was a Russian scientist born in Tobolsk, Siberia in 1834. And he's actually known as the father of the periodic table of elements. And one of the reasons why he's known as the father of the periodic table of elements, he was one of the first scientists to put all these elements together in a chart. And he called this chart, or he called this table, the periodic table of elements. So we're going to start out the next lesson by talking about the periodic table of elements. Thank you.